Dear students, today trigonometric functions of class 11th RD Sharma. Very short answer type questions. Remaining questions we will solve. As each of the following questions in one word or one sentence or as per exact requirement of the question. Here we have to give the answer in one word or one sentence or as per exact requirement of the question. Very short answer. Question number 11. Write the value of 2 sin raised to 6x plus cos raised to 6x minus 3 sin raised to 4x plus cos raised to 4x plus 1 is 2 sin 2 to the power 6x plus cos raised to the power 6x minus 3 times sin raised to the power 4x plus cos raised to the power 4x plus 1. We have to write its value. So simplify this. This 2 sin raised to 6 can be written sin square x whole cube plus cos square x whole cube minus 3 sin raised to the power 4x plus cos raised to the power 4x as it is. This 2, here we can apply the identity a cube plus b cube. Apply the identity a cube plus b cube. A plus b, so sin square x plus cos square x into a square sin raised to the power 4x plus b square cos raised to the power 4x minus ab, so minus sin square x into cos square x. Here we applied the identity a cube plus b cube is equal to a plus b into a square plus ab minus ab minus 3 sin raised to the power 4x plus cos raised to the power 4x as it is plus 1. Now this is sin square x plus cos square x is equal to 1. So which is equal to 2 into 1 into sin raised to the power 4x plus cos raised to the power 4x minus sin square x into cos square x minus 3 times sin raised to the power 4x plus cos raised to the power 4x plus 1. Multiply by 2. So 2 sin raised to the power 4x plus cos raised to the power 4x minus 2 sin square x into cos square x minus 3 times sin raised to the power 4x plus cos raised to the power 4x and this plus 1. This is 2 times sin raised to the power 4x plus cos raised to the power 4x. This is minus 3 times sin raised to the power 4x cos. So we can solve this both. So this is minus sin raised to the power 4x plus cos raised to the power 4x. And this minus 2 sin square x cos square x as it is. And this plus 1 as it is. Now we can solve this sin raised to 4 plus cos raised to 4. We can write this sin square x whole square plus cos square x whole square minus 2 sin square x into cos square x plus 1. Here apply the identity a square plus b square. This minus a square plus b square is equal to a plus b whole square. This identity we can apply here. Since a square plus b square is equal to a plus b whole square minus 2 times ab. This identity we can apply here. So a plus b sin square x plus cos square x whole square minus 2ab. 2 sin square x into cos square x minus this term as it is minus 2 sin square x cos square x and this plus 1, which is equal to this minus this sin square x plus cos square x is equal to 1. So this is 1 square minus 2 sin square x into cos square x minus 2 sin square x into cos square x plus 1. Open this bracket, multiplying by minus sign. So minus 1 minus minus plus 2 sin square x into cos square x minus 2 sin square x into cos square x plus 1. Now we can cancel this negative 1, positive 1 and 2 sin square x cos square x negative and 2 sin square x cos square x positive. So all the terms are cancelled. So finally we have got 0. So required value of given is 0. Question number 12. Write the value of cos 1 degree plus cos 2 degree plus cos 3 degree plus up to dot dot cos 180 degree. So cos 1 degree plus cos 2 degree plus cos 3 degree plus up to dot dot plus cos 180 degree. Its value we have to find out. So we can write this cos 1 degree plus cos 2 degree plus cos 3 degree plus up to dot dot cos 90 degree plus cos 91 degree plus cos 92 degree plus cos 93 degree plus up to dot dot. You can write this before this cos 80 cos plus cos 179 degree and finally cos 180 degree. In this way we can write. Now which is equal to cos 1 degree plus cos 2 degree plus cos 3 degree plus up to dot dot cos 90 degree. And this 91 can be written cos 180 minus 180 minus 89 degree. And this 92 we can write cos 180 degree minus 88 degree. And this cos 93 we can write cos 180 degree minus 87 degree plus up to dot dot plus this cos 78 degree. Cos 78 we can write cos 180 degree minus 2 degree plus cos 79 we can write cos 180 minus 1 degree plus this cos 80 as it is. So which is equal to cos 1 degree plus cos 2 degree plus cos 3 degree plus up to dot dot plus cos 90 degree. This is 180 minus theta. 180 minus theta lies in second quadrant. Second quadrant cos is negative. This is cos, so minus sign. In case of 180 no change, so minus cos 89 degree. Similarly this cos 180 minus 88 minus cos 88 degree. And this cos 180 minus 87 minus cos 87 degree plus up to dot dot. This is cos 180 minus 2. This is cos minus 2 degree minus cos 2 degree, cos 180 minus 1 minus cos 1 degree, and this is cos 80 as it is. So if you notice this, then only this cos 90 and cos 180 will be remaining. Other all terms will be cancelled. This cos 1 degree negative, cos 1 degree positive, cos 1 degree, cos 2 degree negative, cos 2 degree positive. Before this cos 2 degree, this cos 3 will be cancelled. This cos 89 degree, before this cos 90, cos 90, cos 89 positive and cos 89 negative cancelled, cos 88 negative and cos 88 positive, cos 87 negative and cos 87, all the terms will be cancelled. No term will be remaining except this cos 90 and cos 80. So, which is equal to cos 90 degree plus cos 180 degree. The value of cos 90 degree is 0 and this cos 180 can be written 90 plus 90. So this is 90 plus theta. This is 0. 90 plus theta lies in second quadrant. Second quadrant sign is positive. This is cos minus. In case of 90, change this cos into sine. So minus sine 90 degree, which is equal to minus and sine 90 degree is 1. So required value of cos 1 degree plus 2 degree, cos 3 degree plus up to cos 180 degree is minus 1 only. Question number 13. If cot alpha plus beta is equal to 0, then write the value of sin alpha plus 2 beta. So cot alpha plus beta is equal to 0 given. So calculate the value of alpha plus beta. Cot alpha plus beta and the value of cot 90 is 0. So we can write cot pi by 2, cot adjusted. So alpha plus beta is equal to pi by 2. This one condition we have got. So alpha plus beta is equal to pi by 2, or we can write this alpha is equal to, therefore alpha is equal to pi by 2 minus beta, or and beta is equal to pi by 2 minus alpha. So out of these three values we can use any one for finding the value of that. Now sin alpha plus 2 beta is equal to, you can write this sin alpha plus beta plus beta. So this alpha plus beta we can put pi by 2, so which is equal to sin pi by 2 plus beta. So sin 90 plus theta, 90 plus theta lies in second quadrant. In second quadrant sign is positive, this is sin, so plus. In case of 90, change this sign into cos, so this is cos beta. So value of sin alpha plus beta is cos beta, or and also we can apply the different values. Sin alpha plus 2 beta is equal to, we can write sin this alpha plus beta plus beta. So this alpha plus beta we can use pi, and in place of this beta we can use pi by 2 minus alpha. So this is sin pi by 2 plus this beta is equal to pi by 2 minus alpha. This also we can use. So which is equal to sin 90 plus 90, 180 minus alpha. Sin 180 minus theta lies in second quadrant. In second quadrant sin is positive, this is sin, so plus, and in case of 180 no change, so this is sin alpha. So these two answers we have got, sin alpha plus 2 beta is equal to cos beta or sin alpha. Both the answers are correct. This is cos beta and this is sin alpha. One time we solved in terms of beta, one time we solved in terms of alpha. Both values are correct. Question number 14. If tan a plus cot a is equal to 4, then write the value of tan raised to 4a plus cot raised to 4a. So given condition is, question number 14. If tan A plus cot A is equal to 4, then write the value of tan raised to 4A plus cot raised to 4A. This tan A plus cot A is equal to 4. It is given. So we require the value of tan raised to 4A, cot raised to 4A. So first time squaring on both sides, then we will get tan square and cot square. Then again we can square them for tan raised to the power 4A and cot raised to the power 4A. 2 times squaring. Squaring on both sides. Squaring on both the sides. Tan A plus cot A whole square is equal to 4 square. Open this by using A plus B whole square identity. Tan square A plus cot square A plus 2 times tan A into cot A is equal to 4 square 16. So tan square A plus cot square A plus 2. This tan A into cot A 1, because this cot A we can write 1 upon tan A, so this cancelled. We can write this tan A into cot A can be written 1 upon tan A is equal to 16. This tan A cancelled. So tan square A plus cot square A is equal to 2 left. Shift this to this side. 16 minus 2. So tan square A plus cot square A is equal to 14. Squaring on both sides again squaring on both sides, again squaring on both the sides. So tan square A plus cot square A whole square is equal to 14 square. Again apply the identity A plus B whole square, A square, so tan raised to the 4A plus B square cot raised to the 4A plus 2 times tan square A into cot square A is equal to 14 square 196, which implies tan raised to the power 4A plus cot raised to the power 4A plus 2 into tan square A into cot square A can be written. Cot square A can be written 1 upon tan square A is equal to 196. This tan square A cancelled. 2 left. Shift this to that side. So finally tan raised to the power 4A plus cot raised to the power 4A is equal to, shift this to in right side, 196 minus 2, which implies tan raised to the power 4A plus cot raised to the power 4A is equal to 194. This is the required value of tan raised to the power 4A plus cot raised to the power 4A. Question number 15. Write the least value of cos square x plus sec square x. So as we know that cos x is greater than or equal to minus 1 and less than or equal to 1. So least value of cos x is minus 1. So we can use this for finding the least value of this. So therefore the least value of cos square x plus sec square x is equal to, least value of cos x is minus 1, so minus 1 square plus the sec square x can be written 1 upon cos square x, which is equal to minus 1 square 1 plus 1 upon, again this least value of cos x is minus 1, so minus 1 square which is equal to 1 plus 1 upon minus 1 square 1, so which is 1 plus 1, that is 2. So this 2 is the least value of cos square x plus sec square x. Question number 16. If x is equal to sin raised to 14x plus cos raised to the power 20x, then write the smallest interval in which the value of x lies. Here we have to write the smallest interval in which the value of x lies. So since x is equal to sin raised to the power 14x plus cos raised to the power 20x. So we can write this x is equal to sin square x whole raised to the power 7 plus cos square x whole raised to the power 10. 10 to the 20. So, you know, the identity, since sin square theta plus cos square theta is equal to 1, the square of both trigonometrical ratios sum is equal to 1. So here we can get this x is equal to clearly x is equal to 1 for angle x is equal to pi by 2. If we put this angle as pi by 2, then maximum value of this, the value of this x will be 1. How? This sin 90 is 1, 1 is raised to the power 7, 1, and cos 90 is 0. So we will get the value of x is 1. And x is not equal to 0 for any angle x, but x is not equal to 0 for any angle x. We can take any angle this x, but this value of x will not be 0. If suppose we are taking x is equal to 0, this angle is 0, so sin 0 is 0, 0 raised to sin 0, 0, 0 raised to 7, 0, and this cos 0 is 1, so we will get the value of 1, not 0. If we are taking this pi by 2, so sin pi by 2, 1, 1 square 1, and cos pi by 2, 0. So for any angle x, we will not get the value of x is equal to 0. That is why we can say the smallest interval, therefore the smallest interval in which the value of x lie will be 0 to 1. This is semi-open interval. Semi-open interval means 0 is not included here and 1 is included here. The value should be greater than 0 but less than or equal to 1. So this is the smallest interval in which this value of x will lie. This value of this x will lie in this interval. We cannot get x is equal to 0 for any angle x. So smallest interval is 0, 1, and this is semi-open interval. Here 0 is not included, 1 is included, and the value greater than 0 but less than or equal to 1. That's it. Now this is the last question for this very short answer type questions. Question number 17. If 3 sin x plus 5 cos x is equal to 5, then write the value of 5 sin x minus 3 cos x. Here 3 sin x plus 5 cos x is equal to 5, it is given. So we have to find out 5 sin x minus 3 cos x value. So squaring on both sides, squaring on both the sides, three sin x plus 5 cos x whole square is equal to 5 square 25. Suppose this is equation first. Now we have to find out the value of this, so we can consider this is equal to let 5 sin x minus 3 cos x is equal to k. Anything we can consider. So I consider this equal to k so that we can calculate its value easily. Again is squaring on both sides. Squaring on both the sides. So this is 5 sin x minus 3 cos x whole square is equal to k square. Suppose this is equation second. Add equation first and second for the value of k. After adding equation first and second, we can get the value of k, which will be equal to our requirement 5 sin x minus 3 cos x. So adding equation 1 and 2. Adding equation 1 and equation 2. Add left side 3 sin x plus 5 cos x whole square plus 5 sin x minus 3 cos x whole square is equal to 25 plus k square. Open them by using identity a plus b whole square and a minus b whole square. A square 9 sin square x plus 25 cos square x plus 2ab. 2 3 ja 6, 6 5 ja 30 sin x into cos x plus open this bracket by using a minus b whole square. 25 sin square x plus 3 square 9 cos square x minus 2ab minus 2 5 ja 10 3 ja 30 sin x into cos x is equal to 25 plus k square. Now this 30 sin x cos x negative and 30 sin x cos x positive and 9 sin square x plus 25 sin square x 9 plus 25 34 sin square x. Similarly 25 cos square x plus 9 cos square x 34 cos square x is equal to 25 plus k square. So take out 34 common. So sin square x plus cos square x is equal to 25 plus k square. This sin square x plus cos square x can be written 1. 34 into 1 is equal to 25 plus k square. Shift this 25 this side. 34 1 ja 34 minus 25 is equal to k square. So k square is equal to 35 14 minus 5 9 2 minus 2 0. So k square is equal to 9. So k is equal to plus minus 3. Therefore we can say the required value of this 5 sin x minus 3 cos x is equal to plus minus 3. Therefore 5 sin x minus 3 cos x is equal to plus minus 3. This is the required value of 5 sin x minus 3 cos x. So all the questions are very short answer type we have solved. So in this way this exercise completed and this chapter also done. In next class we will start the new chapter. Okay, bye.